Thank you very much for your interest in Flames. In this video, I'm going to provide a very high-level, mostly non-technical overview of Flames. If you're new to Flames, you've never heard of it before, or you maybe even are new to simulation, this is a great video to start with. Let me begin by defining some terms, the first one being simulation. When I say simulation, what do I mean? For the purposes of this presentation, a simulation is computer software and sometimes also computer hardware that is intended to represent the state of a system or a set of systems over time. The systems that we're talking about are aerospace and defense systems such as cars, planes, sensors, etc. We're also sometimes simulating the humans that control those systems, and we're simulating the environment within which the systems operate, such as the terrain, the bodies of water, or maybe the weather, the roads, things like that. Oftentimes, simulations are divided into three different categories. The first category is live. It's real humans operating real equipment for purposes other than the reason for which that equipment was created. For example, if you're training how to use a piece of equipment or you're testing that equipment, that would be considered live simulation. Virtual simulation is what people oftentimes think about when they hear the word simulation. This is when you develop software and hardware to represent real equipment as closely as possible so that real humans can use it and like they're using the real equipment. So this might be a flight simulator where you're in a simulated cockpit and you're training on how to fly an airplane. That would be considered a virtual simulation. The third category is a constructive simulation. In a constructive simulation, it's 100% software. It's a computer program that is simulating equipment as well as humans. In development of simulation and the maintenance of simulation, there are some really big challenges. Two of those are, first of all, that most organizations have unique requirements, and those requirements change often. And this means that we will always have to have many different simulations, and we'll have to maintain those simulations. The next challenge is that simulations are oftentimes very large and very complex systems. And what this means is that it's very expensive and time-consuming to develop those simulations and to maintain them. And these two challenges together ultimately lead to the fact that a lot of organizations don't have the simulations that they need. One of the reasons that simulations are so expensive and time-consuming to develop is that in the past, simulations have been developed uniquely for each set of requirements. So an organization has requirements, they put out a request for proposal, an organization is selected to develop that simulation, and they develop a unique simulation to meet those requirements. This has happened over and over and over again, which is why we have hundreds and hundreds of simulations and why it costs so much, because each one of those has to reinvent a lot of the same software. One of the things that complicates this is that it's very difficult and sometimes practically impossible to reuse software from one simulation in another simulation. So there's unique development and maintenance activities for every single simulation. And that's because the simulations have unique database formats, unique software architecture, unique user interfaces, and software does not migrate between different simulations easily. One of the ways to address this, a more modern way of developing software, is to use a simulation framework. If you use a simulation framework and it's the right framework, it will provide the majority of the software that you need, and all you have to do is develop the specific software that you need for your particular simulation. It's very difficult to develop a framework that is flexible enough to be able to support many different simulations, but if you have a really good simulation framework, that's what it can do. The gaming industry has figured this out. Computer games used to each be developed uniquely with 100% unique code, but that's very unusual these days. The gaming industry has embraced the use of frameworks. We call them oftentimes game engines. Computer games are very often now developed on top of a game-independent game engine rather than trying to build the game completely from scratch. We need to learn from this in the simulation development world. So now I can tell you what Flames is. Flames is a framework that can be used to develop constructive and the software parts of virtual simulations. So as a true framework, it is not a simulation. It is designed to develop simulations. It's not a simulation by itself, just like a game engine is not a game. Over 100 different simulations have been developed with Flames over 30 years. Some of those simulations have been developed by Turnion. Some of those have been developed by other people who've gotten Flames and built the simulations themselves. That's really what it's designed for. We call these simulations Flames-based simulations. So these are all simulations that have been developed using the Flames framework. So let me tell you a little bit more about what it looks like to develop a simulation based on the Flames framework. The Flames framework is independent of any simulation that you would develop from it. The same simulation can serve as the foundation for all different kinds of simulations. The way we do this is we've made a clear distinction between the infrastructure software and the modeling software. Every simulation has both of those types of software, but it's usually all mixed up together. In Flames, we've taken all the infrastructure software and put it inside the Flames framework. The infrastructure software is a software that doesn't model the systems that exist in the real world. It's the database management, it's the user interface, it's memory management, things that exist because we're talking about a simulation and not a real system. Modeling software is the software that is used to simulate the particular systems that are being simulated. We figured out how to isolate those two and how to build a framework that is independent of whatever model it is that you want to develop. One of the magical things that we had to do in order to do that is come up with interfaces that allow models that have been developed to plug into the framework and automatically, without having to do any integration effort, without having to change the framework itself. That allows us to implement the models as plugins. So you write plugins that implement the airplanes and the missiles and the sensors and the automobiles, whatever it is that you want to simulate. They are implemented as plugins, and you get your simulation simply by plugging in whatever models that you've created in your plugins. So you've seen a variation of this chart before. This is now showing how you develop a Flames-based simulation. And as this chart explains, you build plugins to represent the systems, you build them on top of Flames, and you get the simulation that you want. And because all of these plugins are developed using the same architecture, and because they all use the same interfaces that are provided by Flames to plug in, you can reuse those plugins in any combination to create new simulations. So you can mix and match the plugins and load them in any combination that you want to compose the desired functionality. So that's another way that you can save money using Flames, because you can reuse plugins that you've developed for one simulation in another simulation. So in summary, why would you want to use Flames? Well, the single statement is it's to reduce the time and money that you need to get an extremely capable custom simulation. You do that because, as we've already explained, most of the software that it resides in a simulation is provided by Flames. You don't have to develop it. You don't have to maintain it. You don't have to test it. You don't have to keep it up to date with the latest operating systems and tools that are out there. We do all that for you at Turnion. You start off with most of your simulation already developed when you're building a Flames-based simulation. We also help you in the development of your system-specific software and development of those plugins. We have a very, very well-defined architecture and class hierarchy that greatly simplifies the design and development of your simulation-specific software. And as we've already talked about, you save money long-term by being able to take plugins that you develop for one simulation and reuse them in another simulation. Just as important, you end up with a simulation that is very capable and has features that are not found in most simulations, and it's very reliable and very easy to use. That's because this framework, as I've already mentioned, has been used as the foundation for many different simulations, and we've been working on it for over 30 years. So just in summary, these are the types of simulations that you can build using Flames, and pretty much it's any type of virtual or constructive simulation that you can think of. Simulations that do small scenarios or large scenarios with even hundreds of thousands of players. High fidelity models or low fidelity models. And in practically every modeling and simulation domain that exists, Flames has had supported the development of simulations that serve all of these domains. So this concludes my overview of Flames. I hope it's been helpful. I hope you have a little bit better idea now of what Flames is. If you're interested in learning more about Flames, here's some suggestions on videos that you could watch next. One of them is the next video in the overview series of videos, the overview of Flames products. This video provides an overview of the Flames engine products, the Flames developer products, and the Flames optional products. After that, you might consider watching the video on the Flames ecosystem. This is a series of interconnected applications that are used to purchase, install, and run Flames applications. And also it helps support the development of Flames-based simulations. So it's not officially part of the Flames product line, but it's tools that make Flames really easy to use, help make Flames easy to set up on your computer and use. The best thing to do would be to download the Flames developer, which includes the free trial version of the Flames engine, and then the Flames content that is most interesting to you, and give it a try. And along with that, go to the Flames free training videos on our website. There are dozens of training videos that explain how to run Flames applications and how to develop Flames-based simulations. So that would be the best thing to do if you really want to learn about Flames. And when you do that, you'll get the entire Flames documentation suite. Thank you for your interest in Flames, and thanks for watching.